everybody for the afternoon session of the GOES-16 applications workshop. This afternoon, leading us off is going to be Kris, who's the DOE, the Development Operations Hydrologist at the West Gulf RFC, who's going to show us some hydrologic applications of GOES-16 data set. So without further ado, Kris.
All right, thanks, folks. The cases that I'm going to show you today are cases from Hurricane Harvey, and this is the data set that our office was using during the event. So everything you're going to see here is what I was seeing in real time as a forecaster at the West Gulf River Forecast Center. Everything you're going to see here was incorporated into the river forecasts that West Gulf River Forecast issued and some of the decision support that the West Gulf River Forecast provided to the Texas Department of Emergency Management during Hurricane Harvey. So the very first slide I'm going to show you is just an overview of what it is we do to produce river forecasting. It's showing you the points at which GOES can help us add value to our mission of providing river forecasting and decision support to our partners and stakeholders. So a River Forecast Center is a little bit different mission than what a Weather Forecast Office has. We provide the river stage forecast for a wide domain across a huge region of Texas. And our domain includes the Rio on the western edge and on the eastern edge, the Sabine River Basin. We forecast for the entire state of Texas and also for New Mexico and a portion of Colorado. Now, GOES was incorporated in our forecast process. This is a very simplified view of how we produce a river forecast in our office. It takes into account the rain on the ground, the 3-day forecast rainfall that you get, the soil conditions, which we can calculate with a model that we run in our office, lake releases that we get from our partner agencies. All that is combined to produce the river forecast, and that is the stage forecast that is pushed out onto NWSA apps and a variety of other products that are used by our customers and partners to understand the impacts of flooding on their locations. This is also the basis for flood warnings, the warnings that our weather forecast offices put out for our partners and customers. Now, GOES-R was used, or could be used, in several different points of this process. We have been using GOES for the rain on the ground process. So we do take a look at GOES when we're doing QPE and deriving our rainfall estimates. So GOES is used to help us in that first 6 hour window to estimate what the best observed rainfall is in a particular area. It's also used to help us with the placement of rainfall in the 12-hour domain from time 0 out. For soil conditions, this is what I'm going to show you in this application here. Not so much the soil conditions, but how we use the model or use the GOES-R data to tweak our model in real time and produce a better river forecast for our customers. Lake releases, that is an area where I think the GOES has some potential to help us on areas where we do not have gauges or do not have an understanding of what the pool height is on certain lakes, so we can have a better understanding of how full a lake or reservoir is before it begins releasing. And finally, the river forecast side, the end game for our partners and our stakeholders is to make a decision with our river forecast. And so if we can show them a better spatial reference, a better inundation interpretation of what might happen during an event, we can help them make better decisions. And so I'm going to kind of dive into that at the very end of this presentation to give you a sense of how GOES might be able to help with some of that decision making too. And finally, the flood warnings. Of course, it's going to enhance the flood warnings too. So here's the end product again. This is an example of a forecast that was produced during Hurricane Harvey. This is the Brazos River at Richmond. And this forecast was the most viewed forecast in NWS history. We went and looked at the statistics. It was by far the most viewed forecast because of the high impact it had during Hurricane Harvey. You can see how we went from a forecast and how the media picked that up and how it was used for decision support. That graphic on the right is a screen capture we made in our office of the Weather Channel, taking
taking the forecast and putting it out there, helping us get the word out that we were going to potentially hit 59 feet at Richmond at this location. In this location, we had evacuation, mandatory evacuation order to 50,000 people. So we got a lot of attention for that very reason, the gravity of the mandatory impact in this area and for evacuation. Next slide, please. So here is the decision support component. This is a photo that Derek Giardino in our office took while he was stationed at the Texas Department of Emergency Management. And this is a view of their operations room during Hurricane Harvey. This is where a lot of the critical decision making occurs at this level and also at the county level. These folks had all kinds of questions for us, and GOES helped us answer some of the questions that they had about the impacts of flooding in their area. So this has become for us another tool, and a very important tool for us to convey decision support to these folks. They really want to know when this flood wave is going to cause major impacts in their area. The graphic on the bottom of this screen shows an example of some of the decision support that our office produces. In addition to providing help and direct DSS, we've got all kinds of graphics that we produce. And the point and the focus of this graphic is the crest. So everybody wants to know when the crest is going to pass at their location. We focus on that crest forecast, and the decision support that we provide is focused on explaining to them when those major impacts are going to occur. Because once that rainfall drops, it can take days, sometimes weeks, for that water to route downstream and to produce those impacts. The next slide, please. So this is what got us started, really taking a deep dive into GOES during the middle of the event. This tweet came from the weather office in Fort Worth. So Ted Ryan put this together, and this is what got me really thinking about how we might be able to apply GOES to our river forecasting operations. What this shows is a clear sky image on the left of the GOES veggie channel. And you can see that it's fairly clean, fairly clear. You can see some of the reservoirs. And that contrasts with the right-hand side, where you can see a screen capture made during Hurricane Harvey on August 30th, right after the hurricane shifted to the east. And you can see the dark speckled areas that demonstrate where flooding is occurring. And we're going to take a good look at those in just a moment. Okay, so we'll go ahead and get into the demo. And what Chad is going to set up and show you, the first three cases are going to get progressively more complicated. And I'm going to throw more layers on, and we're going to animate eventually at the end of this. So I'll kind of talk through an overview in the first case here, and then we can move on into those more complex cases or more complex details as we move through the case here. But this is a view of the veggie channel during Hurricane Harvey on August 30th. And what we've got up here is a 7 layers that shows the river center lines to kind of make the flooding pop a little bit. And also the basin boundaries that define where runoff focuses. So if you've got water flowing within basin boundaries, it runs all the way downstream within that basin boundary. The water is supposed to stay contained within that basin boundary under normal circumstances. I'll show you a case here where we violated that rule during the event just because of the massive amount of rainfall that we had. But just to give you a quick overview of where we are, he's got the mouse on the Gulf there. This river basin here is the Lavaca. This is the San Antonio right here. This is the Guadalupe. This is the Lavaca Basin right here. And we're moving to the east. This is the Colorado, the San Bernard, and the Brazos. And we're going to kind of stay in this region when we do the tour. Houston is up in here in the upper right-hand corner on the edge of the cloud cover. And we're going to take a tour of some of the features that are shown on these basins just to show you that flooding can be observed with GOES. The first thing I'd like to take a look at, if you can zoom a little bit in on the Brazos, which is, that's the Colorado right in here. You can see some of the dark colored floodwater. So this is this is what the veggie channel picks up. And this is verified as floodwater on the ground. I've got all kinds of aerial imagery, all kinds of confirming satellite information that shows, and ground reports that show that there was a massive amount of flooding occurring in this area. What is somewhat unusual about this, and can happen in coastal flooding when you've got a really flat area, is we've got water that is jumping the boundary. So here's an example where it's jumping out of the Colorado and into the San Bernardino Basin, and that usually doesn't happen under normal circumstances. But when you've got as much rainfall as we had during Hurricane Harvey, we had instances of this happening, and a little bit later, this is going to become pretty clear as to what exactly was going on as we observed water jumping from the Colorado into the San Bernardino, and also from the Brazos River into the San Bernardino River Basin.
So, Kris, if there was just flooding along one of these rivers, you would get light, and it didn't exceed boundaries. These would be very light pixels.
That's exactly right.
They would be highly reflective in comparison, right? You shouldn't get any really dark pixels along these basin boundaries, correct?
That's right. Okay. Dark correlates with more flooding, wetter conditions. And as we move to the east a little bit, you can see some of the areas. If you go up to the north near Simonton, right here, this is a giant pool of floodwater that is above that Richmond forecast point that I talked about earlier, where the high impact event was happening, where we had 50,000 people being evacuated. And so for us as river forecasters, it's really helpful to have this kind of qualitative information to tell us where that flood is, where the pool of water is, where that crust potentially is, where is water being stored at various locations along the river. And so we were able to take the idea that we were having interbasin transfer occurring at various points, and the idea that we've got water being stored in places that the gauging network that we use doesn't necessarily see, combine those facts and use it to adjust our forecast. As forecasters in the River Forecast Center, we have to tweak our model. Our model is never right, so we take this kind of information and we use it to make adjustments to the river forecast. So we were able to take the fact that we knew that we were having interbasin transfer and to subtract flows from those basins, like Colorado and the Brazos, where we knew we were losing flow, and add a little bit, or at least have more confidence that what we were seeing in our observations was actually that interbasin transfer component. It also helped us to know where that floodway was located, so that area that I just pointed out in the Brazos River, it was very helpful to us to know that we had water pooled up there and it was yet to route downstream, and we can account for that in our forecast. So I think that's where I'd like to end in this first part of the demo before we add some more layers to this and go a little bit deeper. And I'll take the opportunity to answer any questions.
All right, let's start first with the audience here. I see a hand back there, Scott.
Yeah, I guess I have a question on the 1 kilometer resolution. Would you ever really get flooding if there wasn't, if it wasn't showing up because it was sub-pixel? I mean, at 1 kilometer, will you ever have a flooding that won't be resolved? I guess is the question at 1 kilometer resolution.
So you're asking, is 1 kilometer enough? Yeah. In this case, yes, it was enough to see. In smaller events, I don't know, maybe not. I mean, more resolution would be more helpful to us. Half a kilometer would be extremely helpful if we could do that at the veggie channel at some point in the future. I don't know too. There's probably some work that can be done with this to increase the resolution by post-processing some of the results against a higher resolution terrain data set. That could really help some of this pop out for us.
So basically, if I'm understanding, they take a day that it's either very dry or just normal conditions and subtract the reflectances so that potential floodwaters pop, correct?
Right, yeah.
Okay.
Some image differencing.
Right.
For normal conditions.
Okay.
There's tons of work that can be done with post-processing.
Let's see. First we'll go to Steve, and then over to Dave.
That is the same question.
basin, make a flood product. Started a couple of years ago as GPSS moving, and now she's making a combined GOES-16 SUMI NPP flood product, which we were providing the feed. She was providing the FEMA during all these floods.
Yes.
And you can see more detail with the SUMI NPP higher resolution with 275-meter resolution. But for big mesoscale events like this, there would be a SUMI NPP overpass and it's got a cloud cover. So if you couldn't see the surface, there was nothing to gain. But she was shooting holes basically through the breaks in convection. And for example, over a 7-hour period, was able to get enough clear pixels to make a flood map that found useful for situational awareness. So that could possibly be a new product, and I'm just wondering what your thoughts would be on that. I would say yes, there are small streams that we don't see.
I mean, yeah, we were looking at some of the Sandy, right? We were looking at some of the work that she was sharing with us during the event, and it was very helpful. But yes, I think that is an area where we have some huge potential. The issue with some of the products that we were seeing during the event is that they were delivered sometimes the next day. So the utility kind of decreases as you get a little bit further behind in time. Some of this, this is obviously in our office in a matter of, minutes, right? The time it was observed. But I do think having some more involvement and some more processing effort would be helpful to us.
And also, it occurs to me that they need to do more validation work. So if you have feedback or have non-negative feedback, I think that would be very helpful.
Yes, and I actually have something I'd like to share with you all on that too. Some very basic websites. We're also going to be taking a close look at some of the studies that have been done by the USGS and Corps of Engineers as they validate and create the kind of decontamination area for us. Yes.
Sure. Kris, can you take us, and this gets to one of the questions that's up here in Slido. You showed the image early on of, I guess, probably the Texas State EOC.
Yes.
Can you describe for the folks real quick kind of how this information is being looked at in your office and an information flow from where you all are seeing to the state EOC and the decision makers there? Can you give us a sense of the timing and frequency and such of those interactions?
Yeah, so what arrangement we have with the state EOC is we have, through our regional operations center, during high impact events, usually someone's stationed there. And that was the case in this situation. And so we had that person serve as kind of the direct point of communication between our office and the state EOC. And the requests that we got were funneled through that person, came directly to our office floor as they happened and unfolded. And so that's how the questions came through and how some of the traffic went back out to them. So that's generally how it works.
Okay. And I said just more for general awareness. Specifically, a question up here now in terms of the imagery. So what, in terms of that information flow, were folks at the end of the line actually using the Vigi channel information, or looking at that piece of data at the EOC, or was it?
Oh no! I mean, these folks are driving fire trucks. They don't have time for that. I mean, they look to us for our expertise, and they look to us to help them size up and make. We don't make the decisions for them, but they look to us to help size up the risk for the decisions that they are making in the EOC. So they do not have time to interpolate imagery for our expertise.
And I think even again to that point, the folks we had embedded there, that the OSIS had embedded there, were they actually using this information, or again relying on you to provide them that?
So the folks that are embedded there that represent the Weather Service, they are looking at all sorts of information. So they're looking at pretty much anything they can get their hands on. So this would be useful to them if it's available externally in real time. I'm doing things in the forecasting office and taking screenshots, sending it to them. As I see things that are useful, that's generally how it's conveyed to the folks in the rock. But having access directly would be helpful for them.
Okay, so back to the local audience, Jordan, and then Zach.
All I wanted to do is make a comment with regards to the fractional pixel color about water. Whole hopefully this will become ever so sharper once we go to fixed grid format, because right now there's a little bit of smoothing that goes on, so that could.
Especially what Kris was using. This is fixed grid.
Oh, that is fixed grid.
Yes.
Okay.
But there was confusion yesterday. Remember there was some comments about this imagery didn't look the same or something. That's because they're not, I think, because they're not used to it. But Kris in the office was probably using the interpolated grid, which is definitely not superior to that. This is far superior. Yeah, you're right here. That's a good point.
Okay, in the back. Oh, I can remember.
I wasn't operating correctly. So having worked in a number of flood disasters, this sort of image at this resolution would be tough to use at a decision-based level at the local community. The resolution is very difficult because when you're thinking about evacuations, thinking about flash flooding, you can make a lot of poor decisions using something like this resolution. This is a great image, however, for situational awareness. FEMA and Kris Vaughn and that group, when they look at this type of information, it helps them understand the general location of where this flooding is occurring, so that they might send resources in those areas to do additional investigation. I would just caution the use of something like that resolution. You can also pick up high moisture areas, if there's flat edges. You have to be real careful with using that band. NDVI, there's other methodologies and different things that you can use to pick up water features that are commonly used in land remote sensing that would be even better to what you're looking at with this single band here. So we are looking at just the single band, correct?
Yes.
However, I mean, these things are, as we get more better resolution, these things are incredibly important in determining this. One of the things that would be interesting, I think, is, like you mentioned, looking at that inundation modeling after the USGS Army Corps of members putting that together, and see how well that lines up with this. When you're looking at 1 kilometer resolution, I mean, you could have 10, 15 houses in there. Looking at how well those line up so that the next time you are faced with something like this, you can see whether or not, and what streams were showing the response here. Things that might have, say, a 40 square mile drainage area or less, you may never see in this images.
Those are great comments, and yes, I want to definitely agree with you on the fact that this kind of inundation information, if you show this as an inundation or imply that it's inundation, it should most definitely not be used at the neighborhood level. It is, in fact, way too coarse. We'll get a little bit further into the demo where I'll show you how some inundation mapping that came from a credible modeling package that's not GOES was applied in this situation to help us do at least some ballpark estimates of was an impact going to happen or not in an area near Beaumont. So we'll get to there at the end of the demo, but I agree with your points that this should not be used at the neighborhood level. And in fact, it was not applied at that level during the event for the GOES stuff. Great comments.
Okay, I guess we'll move on.
Yeah. Should we add some of these layers?
Yeah, let's go ahead and turn on a couple of other layers. Let's start with the cool floodwater layer. Okay, so we talked about this, a little bit of this already. So this point here on the left was the area on the upper Brazos where we needed to know that there was water pooling. To the right, those two polygons, those are just kind of areas of interest. Those are the Addicks and Barker reservoirs in the Houston metro area. These were a critical component of the Houston event. And so those are the flood pools. You can see the flood pools. I actually digitized those directly from an outside mapping source. So those are the actual boundaries of the flood pools during the event for some aerial imagery that I identified, so you can see what's happening with those flood pools. And further to the north, you can see some interbasin transfer happening. If you would mind turning on the forecast group, forecast boundaries. EWRs.
Oh, yeah, thank you.
Yes, so that turns the boundaries on. And here's another example. Here's Cypress Creek right here. And so this is a known area where we have interbasin transfer occurring at lower frequency events. And so that was actually draining into the Addicks Reservoir Pool. So you can see some interbasin transfer occurring. There should not be water on those boundaries under normal conditions under a normal flood event, but when we have interbasin transfer occurring, you will see those boundaries inundated, and that is useful qualitative information for us as forecasters. Let's see, what else do we have to turn on? So let's go ahead and turn on the levied areas too. So I digitized some of the areas that were around the Richmond forecast point. So this is the Brazos River at Richmond. And you can see the blue highlighted areas. Those are areas that were levied during the event. And it's important to note that none of these areas actually overtopped or breached. So everything remained dry, although you can see a little bit behind them. So what you see behind them in the GOES channel, there is a couple places where you've got some darker pixels, especially in the areas that are a little bit closer to the river channel. Those were actually inundated with local flow. So they didn't breach, but we had so much rainfall falling on top of these levied areas that they had to pump them out to try and keep them dry. So what you're seeing is water from interior drainage and from local flow that fell on top of the levee systems, and that needed to be pumped out in order for those systems to remain dry during the event. Let's see further. Let's see what else we have to show. If we back out just a little bit, I'm going to show you some imagery shortly of a drone flight. We can turn that later on too, just so you've got a point of reference. You can see an area that was flooded. So this is near the bottom, and you can see that drone as you look. Keep this in mind as you look this direction. The drone's going to be traveling to the west. You're going to see an area that was inundated pretty well, and that is right over Oyster Creek, and that is another area of inundation and interbasin transfer during the event. And you can see several locations along the Brazos where we had inundation and interbasin transfer occurring. This was a major area. And much further to the north, this was a huge area. We had water crossing back and forth. And again, keep in mind, we have no stream gauges that can possibly measure this for us or quantify this factor. So I'm trying to figure out if there's any way we can use GOES and some other hydraulic methods and some other calculations to put a number on any of this. Does the return from GOES correlate at all with depth in the area? Can I get a ballpark idea of how much flow might be transferring back and forth, or might even be in a channel in an area where we don't have a gauge? There's multiple ways in which we could try to analyze this and pick it apart, but I think there's some work to be done in the future to try and put a number on some of these returns and quantify this. Anything to us is helpful during an event when we're flying blind in some of these areas where there is no gauging information, and we've got no way to understand what's happening. So here is the drone flight that I described. As you're looking to the west, and you can see that entire area from the Oyster Creek Basin that is sitting on top of all the way out to the Brazos. This is the highway corridor, and you're looking west down that corridor, and you can see it's just nonstop water all the way as far as the eye can see. So this is, I don't know if there's anything else you can turn on. What about the mirrors?
So Kris, that would be looking in this area basically, correct?
That's right.
Yeah.
Into the Brazos, towards western Lagoon.
Okay.
And so before we wrap this section of the demo up, let's go ahead and look at the GEARS imagery from August 30th. So you can see a direct comparison. We weren't able to shade this. It would have worked a little bit better to shade, but we can still kind of get the idea. So this was collected from an independent source.
I'm going to clean some of this up so we can toggle this on and off. I think, in my opinion, most people should be very impressed by
Can you give us a sense of what is this year's what?
Well, this is the stuff that Sandy gave the post-process. Dig out
Mapping, the flood mapping.
Yes, the flood mapping.
Is there any particular areas you'd like to show, Kris?
Yeah, let's zoom in to this area because this is we're going to pick it up after section 3. So this is the basin transfer that's happening between Colorado and the San Bernard. And so this is going to validate something that I'm going to show you in a time animation in that section of the demo. You can see in this area, seems like there's quite a good depth of water being stored on the upper end of this. And you're going to see this water break out and move. You can actually see it move in the next section of the demo into the San Bernard Basin.
That's interesting.
Just for clarification, so you said this is flood mapping. Is it just, this is ground that's wet that in background field is not normally wet? Is it as simple as that? Okay.
All right, we'll start locally, Rob.
So there's a couple areas on there that I've seen some really dark pixels. You go right there, right there. It doesn't have the green covering it. There's a little one further north as well. What do you think is going on there?
They could be wet. I mean, I have aerial imagery that we can take a look at if you'd like to look at it after this. But that could be a reservoir, it could be a small lake. It probably is wet.
So you think because this is the Veers mapping we're seeing in the green that maybe it's a place that's historically wet? Is that what you're guessing?
It could be, yes. So that's near Holiday Lakes, and if I remember right, there are a couple of reservoirs and small water supply features there. They're all over the place. If I had that layer or that lakes layer on this, we'd probably be able to pick those out. We'd do a little bit better job of picking those out.
Yeah, some of them are included in the list. But this one in particular, that's probably a reservoir for us.
Yeah, that looks like a reservoir, especially being more upstream.
Because everything's so dry around this, it's highly reflective.
But keep in mind, this area got in excess of 40 inches of rain. I mean, everything's wet at this point. This is the point at which the work being moved out, and they just got 40 inches. So there's very little that's actually dry in this area.
Now, Kris, just for clarification, you all were not looking at the Veers overlay during the event where you were.
I'm sorry.
You were or you were not using the Veers overlay flood mapping overlay during the event, or you were not?
We were looking at it the next day as it was delivered. We didn't have time to study everything, but this was available on the fly as we were doing the forecast.
Okay, and that gets back to the latency issue you brought up during here. Okay. Let's go to the slide over for a question. This one's been up for a little while. In some areas, the dark pixels on the veggie band are offset from the river as shown by the map layer. Is that a mapping error, or is that how the water actually flowed?
Well, I guess it all depends, but yeah, I don't think that this is 100% correct in terms of being geospatially referenced. So I think, yeah, that is a factor here. And in other areas, that's actually how the water flows. All the interbasin transfer that I pointed out, as it's all set in the river, you're going to see that in just a minute. Was actually a phenomenon of the river.
How much of it is that a big deal for you? I mean, like we're taking a look at this river here, and you can obviously see where it's flowing, right? How much of an issue is it off of Pixel or to sort of what you guys do?
For what we're doing forecast-wise, doesn't really matter. We can see that it's flowing in one direction. That's useful information. For us, the real factor in how we modify the forecast within our office was knowing that it was jumping from one basin to the next. So it doesn't really matter for what we're doing in our office, whether it was completely spatially correct. For somebody that's looking a little more at the inundation mapping element, it's going to be more important.
Sure.
Yeah, so Chris, that river there that Chad zoomed in on, that one lines up pretty good. But Chad, if you'll slide to the east, I forget which river that is there, or between, no, up to the north, between El Campo and Eagle Lake. Yeah, that one right up in there. There's a large area where the dark pixels are for a long stretch that are consistently offset to the east.
Yep, right here.
Of where, yeah, that one there. If you'll, and show where that is, Chad, with the mouse pointer.
That's a great observation. Wait till we animate it, you see what's happening.
Where you're pointing right here?
Yep.
Yeah.
Yeah, this is a floodplain. So these river seam streamlines, those are an idealistic representation of where the USGS or EPA or whoever digitized the river set thinks the river flows. But in reality, this is a floodplain, and floodplains can be miles wide. In fact, the Brazos River at its widest point was almost 11 miles wide. So it's not surprising to see that water is being stored in a floodplain that is offset from where the stream centerline was digitized.
Okay.
No, yeah, I think so.
Okay. Other questions from the audience here?
Not a question, but just, I'm not familiar with the flood map that Sandy made, but just so that people realize that it was not possible until GOES-16. It's not just the spatial resolution. We haven't talked a lot about spectral, but it uses the visible band, the 0.86 digiband, but also the 1.6 micron band, which does things like removing cloud shading and other artifacts to apply both MPP or J1 and also GOES-16. And also working now on difference maps, and you can see receding of the water, which she hadn't done before. And so she's starting to look at that, and that might be also useful for your work.
Yes, the differencing, I think, would be a huge factor for us in understanding where we're gaining and losing flow. And that literally can help us calculate volume-wise. But that is something we could factor into the forecast, is knowing the differences from time to time, time slice to time slice.
All right, one more. I guess we'll kind of hit the first one to some degree, but looking at the second question here on slide, what additional high-resolution imagery have you all or do you all use when attempting to analyze some of the inundation? In addition to what you shown here.
The imagery that I've shown here, okay, so Noah actually did some very detailed aerial imagery flights of this, and I've got an ArcGIS Online site that I've got, I just published it on the NOAA Geo platform. You can take a look at that after this session if anybody's interested, but that is a major source for validating this information. They've flown quite a bit of the area. There's also countless CAP imagery flights. There's stuff that I mentioned the USGS was doing on the ground in creating a final study using high water marks, survey information, and digital elevation models. This has to be one of the most well-documented floods in history, just all the information that's being reported. So all of that can be pulled together and used to validate this approach. There's also the MODIS imagery. It goes on and on. There's lots of other satellite overflights that were done during the event that were captured by the University of Texas. So there is a ton of data to be used to validate this.
All right, so one final question, and actually I was thinking about this too. Do you like or use the enhancement for the veggie band? This enhancement. So again, this is default color curve with the D2B. We always use grayscale enhancements for the near IR for continuity with the infrared. So I guess make some comments on whether or not I guess you or anybody on your staff perhaps in looking at this data over that time has attempted to enhance it in any way or use additional color curve / enhancement techniques.
Yeah, we talked about, maybe if there's a way to start a coloring where we think, a pixel is a low enough reflectance to be, to be floodwater, basically, right? Yeah. So that would jump out a little more than other pixels. Even when I was looking at this, it's difficult at times, but Kris is the expert, and he was showing me things that I was kind of pretty shocked at, like crossing the boundaries and of the basins and how that doesn't normally exist and things like that. But it's difficult to see, and I think maybe a better enhancement would help. I think the question is, what are your comments on that?
Yeah, what we have to do, because it can vary by season, vary by background vegetation, background soil moisture conditions. I'll do quite a bit of work to factor out those, but there's got to be something that we have in the color curve that really make it pop. Blue would be great too if we could go to something.
I wonder if we could change the black to be navy and around 50% have that be like a lighter green and then transition to white on the upper end.
For clouds.
That may add some color while kind of maintaining the same grade.
Right. All right. So Chris, now you want to kind of add the element of time, right?
That's right. So
All right, let me know what layers you'd like me to add and where you want me to zoom in.
So let's turn on the interbasin transfer layer again.
Okay.
And what we're going to do is we're going to zoom into this area right here. So this is the Colorado, this is the San Bernardino. And what we're going to see as soon as it starts to animate is you're going to see water moving from Colorado into the San Bernardino. Watch the pixels, watch that area, that polygon darkening. And that is a flood wave that we calculated to be traveling about 1 mile per hour from basin to basin. We just happened to catch this on the 30th. And it is what it is. It's water traveling from one basin to another. And you can see that flood wave, before it has a chance to fill in on the San Bernardino side completely. You can see that water traveling from the Colorado River into the San Bernardino. Did you want to highlight the returns too so we can see?
Yeah, so here is, so this is basically 16Z. Let me magnify this a little more. So something in there, pretty high reflectance, low 20s. And then 5 hours later, you can see how quickly things change. This isn't flash flooding, right?
No.
So why don't you comment on that? Because it's hard, people from the flash flooding, a lot of people get affected by that. But
Could you point out how much time has elapsed because it's incredibly tough for folks to see the line now?
so between here and here, this is a 5 hour change. So this is 16Z, and this is 21Z basically.
More than that.
Right.
Yeah, so you can sit there and count the pixels, you calculate the speed that it's traveling, and it's traveling at a very reasonable rate, slower than what most people can walk. That's what I would expect to see with a big flood like this, with a very flat terrain that is down there on the coastal area.
I was just thinking about George's comment with flickers, and you're seeing some clouds.
Right.
Kind of the northeast. The last view frame is right, kind of right over the able to differentiate some of them.
So what is the application to something like this? When you see this happening in real time, can you talk about how you use this information?
Yeah, so we didn't keep a slide that showed the forecast being modified, did we?
I don't think so.
Yeah, so what I would be doing real time in my model is if I had a forecast crest on Colorado that's was going up and say maybe going to crest at 25 feet, I might knock that crest down to 24 feet or 23 feet. I might take a little bit off the top of that crest and move that volume from the Colorado River into the San Bernardino River. It's going to show up in the San Bernardino. So I have some examples and some screenshots on my desktop of how exactly we did that and the types of modifications that we would make to our model, but it basically is moving volume from one basin to the next.
Is there any other highlight?
And the other kind of GOES thing is the clouds. You
let's go internal folks. Yeah.
I was going to comment, the WFOs issue the aerial flood warnings for this type of a scenario, and use this to delineate the area that should be under the warnings, so like a square or something that actually really precisely draw your warning area based on this.
That's probably an appropriate application for this, so it should be that scale.
What kind of DSS would you be able to provide this to a partner, and how will they impact?
Well, for this particular application, so the partner would be most interested in the crest forecast and how it changes and impacts the crest. So what we would be providing them is our typical, the crest is going to end up being 24 feet in Colorado Port rather than 23. Does that answer the question?
Yeah, I'm just curious if the impact of that flood wave in the interchannel basin, what kind of, I mean, is that, are there responders out there in that area that you could then give a heads up to, like, it's going to get higher water level? Is there a DSS impact there?
Potentially, in this area it's fairly unpopulated. This is probably just farmland, to be honest with you, in this area, but yes, if this were to happen in a major metro area, in most cases, folks would have factored this into their building when they built homes in certain areas. You would think, they knew that they were in the middle of a floodway, but there could be a DSS component of this. I don't know. I haven't thought looking at the basin transfer side about how that would actually apply to something on the forecast or changing the forecast.
Thank you. Yeah, I just thought it was, I mean, if I'm reading a partner in the EM that's going like that, that might be something, hey, we've got a bunch of responders out in this area, the waves coming in, how you might need to respond on, DSS aspect right there with the movement.
Yeah. So if you were, this was kind of in the western U.S., I can see your point with that, and this was a rapidly moving wall of water, you'd be able to track that all the way down. This was a dam break. Absolutely, I see the application of that, being able to monitor that dam break floodway all the way down. This is probably a 1 foot to 3 foot, wall of water at most. I don't even say wall, it's just a flow. Slow flow that's moving on at 1 mile per hour. So I don't see it other than the fact that it's going to inundate an area, or you can monitor the inundation as a huge tidal wave or a huge threat that's going to wipe folks out off the highways. It's a slowly traveling flood, but in this case, but yes, if it was a dam break or something more significant, a rapidly moving wall of water, there can be a huge DSS component to that. Just not in this case.
Yes, just one comment about using the digital values across basin transfer area is that during this time period of the spook, the whole image is dark as you get later in the day. So you have to take that into account too. Using the actual digital values.
I didn't hear everything. I'm sorry.
I said one word of caution using the digital values in that cross basin transfer area is that the whole image is darkening during the time of the swoop. So you have to take that into account too.
Sure. Okay. So here's a good take a look at. So there's 28 December reflections at 1602. 5 hours later, it drops 3. Right. I go here 23, dropping to 11. It's a significant drop. While I do understand that, there's significant darkening, within that area.
What happens here? This type of water in this area, it changes the line.
Right.
So with regard to the crest forecast, the utility of the crest forecast is to combine that with historical inundation maps to project flooding, is that correct?
Can you just repeat that?
The use of the crest forecast
what we do with that is we publish that on NDS AWIPS, and that is used by decision makers to determine what their level of risk is. So we put everything out on water.weather.gov. That's the main website that this goes on to. We do not, and it is not, to web services, not currently in the business of publishing real-time flood information maps. So this is all factored into a Kris forecast. That very first product that I showed you, I think it's slide 3 of the demo. It showed you the line, the single line, that represents the crest of the river. So that the times really it flows of the river. That is what this information was factored into the modification of that forecast. That is the product when they focus on DSS in this case.
I guess my point is that forecasts historically have been used to kind of infer what now you can potentially see with satellite data and updating the inundation maps for historical purposes and future purposes.
Yeah, but we've got to look forward into the future in the middle of one of these events. And this is helpful observational information for us. But it tells us what's going on right now, but we need to know what's going to happen, and we need to know what's going to happen 12 hours from now, 4 hours from now. So this is extremely helpful to know where we're at right now. Okay. All right, so let's get into the final demo here. And again, we're back in the Texas Department of Operations, the TM operations area. And they came through our DSS coordinator with a question on the 1st of September about a staging area that they had in Beaumont. So this is the Ford Park area, and it was just, we had a ton of requests that day. This one really caught our eye. We thought we could help with this one, and this was a little bit of an extension of our typical forecast routine in answering questions. But we will answer any question, at least try and help them and let them know, try to answer their questions as best we can. So this was about the staging area in Beaumont, that they had everything. They had a bunch of trucks, a bunch of military vehicles that they were using for swiftwater rescues, and they needed to know, was that at all at risk? And so we had to do some work outside of our normal forecast operations to help answer that question, or at least give them a reasonable best case for that area as to whether it was going to be impacted by floodwater. And so if we could open the map again, what I'm going to show you on the map is the imagery from September 1st. And I'm going to show you the location of this staging area relative to the imagery. And so that pink polygon there is the staging area. And you'll notice that one particular feature of the location of that pink polygon is the fact that it is outside of our normal forecast area. So if you zoom out just a little bit, you can see that the basin boundaries for forecast basins end a little bit north of Beaumont there. And they needed to know if the flows that were coming down the Neches River, which is right here, this is the Neches, were they going to be impacted by that? And that was a difficult question to answer this day, because we had lost the gauge of the saltwater barrier, which is the point just above the basin boundary. If you could turn on the AWIPS layer, that shows the locations of our forecast points. Right there. So this was a gauge where we got reliable readings. This NSB-T2. Here, this Beaumont gauge was just below that, and that was signal only and observer-based readings. So the saltwater barrier gauge, the NSB-T2 gauge, we had lost the gauge. They put a temporary gauge in. We lost that gauge. We had no observations coming in during the middle of this event. And we had to make a best estimate of how much flow was coming down the Neches based on doing a mass down on subscreen and determining whether this point, which was all set from the Neches River, was going to be impacted by the river system. And the only way we knew how to answer that question, or at least give them a reasonable estimate, was to put in a set of flows to a dam break model that we use in our office, operationally known as DSS-WISE, and try to extend the mapping that was produced by that dam break model to kind of size up the situation to determine if there was a risk to that staging area. And so that is exactly what we did, is we ran a dam break model with 300,000 cubic feet per second time restricted flow, and came up with an inundation map for that area. And what I'm going to show you is the values that are 1 foot or greater for that map. So we knew the limitations of this model. We knew it was a dam break model, and it was only loading flows at one point. So we had to take the results with a grain of salt and know the limitations in applying this information. But we could use this in this coastal floodplain to size up what we thought might happen with that 300,000 peak coming down the Neches River. And so what you're seeing here in the blue shaded area is the results of that dam break model run. And you can see the relative position of the polygon in the staging area to the dam break model results. So before releasing this information to TDM, and our result from this, or our take on this, was that they were going to be okay, that they were on high ground, and they didn't have much to worry about. That the folks closer to Beaumont and Porto had much higher impacts to deal with from this event. But before we before we release this information, we wanted to do due diligence in validating this mapping, and we went on quite a hunt to look for whatever we could find during the event to help us see what was happening on the ground. We were scraping Twitter. We were looking for helicopter flights, drone flights that were done in this area that folks were listening to YouTube. We were looking for anything we could find media-wise, news report-wise. And we were having quite a time trying to organize and do this quickly. We didn't have a heck of a lot of time between forecast cycles to get some more information. But we did end up looking at GOES, and this really did help us understand and help us validate, or at least quality check, our answer before we released it to the Texas Department of Emergency Management that they were going to be just fine. And so that's what we did, is we took a look at GOES later in the afternoon. I captured some of the imagery. I think it was around 3 or 4 o'clock. We took a look at this in the afternoon and saw that the areas that the dam break model were showing as at risk were fairly well aligned with what we were seeing through the GOES imagery. So this served, in addition to all these other data sources that we kind of assembled together and used to ground truth this served as a tool which we used to ground check and validate an extension of a dam break model that we used for inundation mapping to understand whether they were going to be impacted or not. We didn't release these maps to the public. We didn't give them to anyone outside our weather office other than to TDM, so they have them for the reference. But we did provide them with this answer and provide them with this point of reference and context on the limitations of this information. This is how GOES served as a method by which we were able to reasonably ground truth the maps during the event and help this partner understand whether the staging area that they had set up was going to be impacted or not. So yeah, here's a photo of the staging area. And you can see the extent of the mapping in this area, and the fact that it was going to be in the zone that's main body on the camera there.
Actually, can you go back to that?
Yeah.
So the little tributary or whatever that kind of flows right to the north, does that just stop if you go farther left? Northwest relative? I mean, it seems odd. But it's just.
Yes.
I noticed that, the reason I'm asking, because I noticed that in the shading, the inundation shading there, that it also stopped at about the point where this building or structure is located. And I thought that was kind of concerning.
That's a limitation of the dam break model, that we're loading flow this way and there is other flow coming this way, but this isn't a huge
about water that's running down from the headwaters because it's already shown in this area.
Okay, sorry.
Oh, that's good. You're fine.
So the takeaway is you can use flood inundation, and we can observe flood inundation with the GOES SGA in real time. The visualizations of flood inundation can be enhanced with GIS layers. And GOES-R. That's what we really need as hydrologists and as forecasters to make the information relevant, to make it useful to us so we can modify the forecast. We have to know what's going to be impacted. And finally, that we can take these visualizations of flood inundation in real time and use it and assimilate it into near real time flood inundation maps to validate our near real time flood inundation maps.
All right, take just a couple of quick questions. Anybody here in the audience? Final questions for Kris? Okay, we'll turn the slide over for the last bit here. It's like Scott Bachmeyer. Did y'all also look at the snow ice band imagery to help diagnose areas of flooding? I don't know if you can throw that up on there, Chad, or not, just out of curiosity, since we can.
We have looked at it, but it's an interesting question.
Maybe you can talk back and forth.
Snow ice and the land surface is dark. It is somewhat brighter than the visible band, but it's still pretty dark.
Okay, one final question. I guess, Kris, this goes to the DSS piece, I think, of the presentation. In the WFO, there's a strong emphasis on IDSS, for example, ensure forecasters learn to effectively communicate their expertise in messaging that's meaningful, understandable, and actionable for mitigating risk. How are the RFCs addressing this similar sort of issue? When you touched on a couple of key points there, maybe you can expand a little bit.
Yeah, so again, we are addressing this issue during the event. We had an IDSS communicator that was actually a member of the ROC team working directly with me every day. He was embedded in the operations area. Outside of that, we have all kinds of calls with various stakeholders, all other offices during this event. We're doing a fantastic job of pulling us into some of the relevant conversations regarding the IDSS. We were a resource to them and to their stakeholders and partners during this event. We also have an IDSS playbook in our office, so that is a point at which our office at the River Forecast Center is trying to move forward in pushing the IDSS mission by developing our own office playbook, which includes our own situational awareness levels that help us working with the ROC and with some of our other forecast partners. We have a whole group of standardized graphics and methods for producing those graphics for IDSS during the event. We have a very strong social media presence in our office, very strong Twitter, Facebook presence, and we produce graphics on a frequent basis. But I think the point at which we have the most value is those calls and having a direct partnership with other forecast offices and the stakeholders being able to provide that information directly to them during those support calls.
And of course, the internal communication, right, between the regional ROC, RFC, WFO, and interest department, things like AWIPS, AWIPS chat, AWIPS collaboration, those mechanisms for communication are constantly open.
Absolutely, yeah, we rely on AWS chat. It does become kind of difficult to monitor all the different channels that are out there, but we rely on chat, and that was our direct line between the Texas State Operations Center and our office during the event. So we got Eric and Jason and some of the other folks down on chat.
Okay, well, thank Kris.